When we interpret a let type, the result is the result of interpreting the body. If the body is the number 1, then the result will be int v1. More interesting thing that we can do inside the body is apply the constructor function. For example, construct an apple. In this case, interp needs to return some sort of a value that represents the instance of an apple variant. It's not immediately clear what value to use. If this was split, then we might expect to see something like this. The result is an apple v, which holds an int v1. We could imagine doing something like this, but it would require us to make a new split variant every time that there was a variant inside of a Mo program. And that's not something that really makes sense to do. We'd be setting ourselves up for a conflict between the variants that make sense to define and split for the interpreter and the variants that happen to get defined in the Mo programs that we're interpreting. It's better to keep these two separate. And so instead, at the split level, we'll introduce a generic variant v value, where a variant v holds a tag and then a value inside. If we have an apple, then the tag is apple and the value is our int v1. If we build a banana instead, the variant tag is banana. Another thing we might want to do is use apple by itself inside the body. Split would let us do this, so why not? Let's do it in type Mo as well. Apple should be a kind of function that takes in an int and constructs an apple variant. For us, it makes the most sense to represent this with a constructor v value. So a constructor v is similar to a closure, but it's got built-in support. We'll know just from the tag apple what sort of function this constructor should behave as. Similarly, for banana, we would get a constructor value back with the different tag for banana. Let's look now at match. If we match on the variant apple3, we would expect to go down this apple case, which should bind the variable a to the value 3. So when we return a, we expect to get back int value 3. If we match on a banana instead, we shouldn't go down the apple case, but instead go down the banana case. B is bound to the function inside, so we can call b of 7 and get back the int 10. This should all be pretty familiar. This is the kind of code that we could write in Split all semester, and we'll have it running in Mo, just with a slightly different syntax for type definitions.